Okay, today I'm going to talk about section 3.9, the antiderivatives. This is our line. The first, motivation. Second, what is an antiderivative of f? What is a differential equation? What is the graph of an antiderivative of f? So, the physicist who knows the velocity of a particle might wish to know its position at a given time. An engineer who can measure the variable rate at which water is leaking from a tank wants to know the amount leaked over a certain time period. A biologist who knows the rate at which a bacteria population is increasing might want to deduce what the size of the population will be at some future time. In each case, the problem is to find a function capital F whose derivative is a known function f. If such a function capital F exists, it is called an antiderivative of f. This is like a definition. A function capital F is called an antiderivative of f on an interval I. A definition, capital F prime of x equals f of x for all x in I. This is definition. I'm going to give the one example is like this. So we know, so x squared, the prime is 2x. So we call, what's like 2x? The 2x is the derivative. Derivative of x squared. What's like x squared? X squared is the antiderivative on antiderivative of 2x. This is like exact definition of antiderivative. Now I give the more examples. The capital F of x is 1/3 x cubed. I want to take derivative. Capital F prime of x is 1/3 x cubed prime. So we have x squared. So this is the little f of x. The capital F is an antiderivative of the little f. So the capital G of x is 1/3 x cubed plus 1. Take derivative. The capital G prime of x is 1/3 x cubed prime plus 1 prime. The 1/3 x cubed prime is x squared. 1 prime equal to 0. We have x squared, same little f of x. So G is an antiderivative of f. So what does it mean? So we have infinitely many antiderivatives. You can change this one. 2. We have same answer. Change 3. We have same answer. So we have a lot of members of family of antiderivative f of x here. So x cubed plus 3, x cubed over 3 plus 3, x cubed over 3 plus 2, x cubed over 3 plus 1, x cubed over 3, x cubed over 3 minus 1, x cubed over 3 minus 2. We have the infinitely many antiderivatives of x squared. So we have one general form. The capital H of x is 1/3 x cubed plus c. The c is any real number. So this is the same to the capital F of x plus c. The take derivative h prime of x is 1/3 x cubed plus c prime. So we have 1/3 x cubed prime is x squared, the c prime equal to 0. So we have x squared. This is like little f of x. So we call the capital H is an antiderivative of f. This is like exact definition. So here, we call the most general antiderivative. The theorem. The capital F is antiderivative of f on an interval I. The most general antiderivative of little f is capital F of x plus c, where c is an arbitrary constant. This is like a whole idea. I can remind again. Was it like a definition of antiderivative? So here, you can take derivative. Find little f of x. So we call this capital F. This capital F is antiderivative of f. So was it like f of x plus c? You can take a derivative. So we have capital F prime of x, c prime equal to 0. Just little f of x. So we call this capital F of x plus c is the most general antiderivative. This is like a whole idea of the antiderivative. I'm going to make a table of antiderivative formulas. So assume that capital F of x equals little f of x. So what does it mean? So the capital F of x is antiderivative of the little f of x. The g prime of x is g of x, same. Capital G of x is an antiderivative of little g of x. The k is like a constant. So we just find table. The kf of x is function. Was it like antiderivative? K capital F of x. Why this is true? We can think about this. K capital F of x prime. So what happens? Some the k is like take out. So we have f prime of x. This is exactly k times the capital F of x is little f of x. So we have it. So antiderivative. K times capital F of x is like antiderivative of little k f of x. This is like a whole idea. The f of x plus minus g of x, the antiderivative is capital F of x plus minus capital G of x. So what's that? So we have the like this. Could you something like turn off your video and your audio, please? Could you turn off your video and the audio? So here, we have the capital F of x plus minus capital G of x. You can take derivative. What happens? The capital F prime of x plus minus capital G prime of x. So capital F prime of x is here, little f of x. The capital G prime of x is exactly G of x. So what's that? So capital F of x plus minus capital G of x is exactly the antiderivative of little f of x plus minus G of x. This is like a whole idea. So what is the antiderivative of k? So what do you think? Could you write your answer? The antiderivative of k. So what does it mean? So which function prime is k? You can find this one. Which function prime is just k? What is antiderivative? One more. Could you like some of the close, some of the, your audio and your like video camera? Could you like turn off? So the zero? I don't think so. Here, the zero prime is like zero. So one example is like which function prime has 3? What's that? What do you think? The which function prime equal to 3? Yes, 3x. So we have 3x prime equal to 3. So same. Kx prime equals k. The antiderivative is kx. Was it like x to the n was antiderivative? So we have the like this one here. We can check 1 over m plus 1 times x to the m plus 1 prime. What's that? The 1 over m plus 1 is coefficient, take out. 1 over m plus 1. X to the m plus 1 prime. So we have 1 over n plus 1. So here, m plus 1 is like down times x to the m plus 1 minus 1. So m plus 1 is crossed out. So we have x to the power n. So this is antiderivative. X to the n. Was it like antiderivative of x to the n? 1 over n plus 1 times x to the n plus 1. It's like antiderivative. So one example. So which function the prime is like x squared? You can use this formula. Exactly 1 over 2 plus 1 x to the 2 plus 1. This is antiderivative. Exactly 1/3 x cubed. This is antiderivative of x squared. This is the idea. What's the antiderivative sign of x? Could you turn off your audio and like video camera, please? Please turn off your audio and your like video camera. Is possible? Could you check and turn off? So was it like a sine of x? Was it like antiderivative sine of x? So we have sine of x. The which function prime is sine of x? Was it like antiderivative of sine of x? So what is the answer? So what do you think? Yes, cosine. So we have this is a negative cosine of x prime is sine of x. So we have negative cosine of x. This is like answer. Could you like turn off your audio and like video camera, please? So could you check it? Is it possible? Could you turn off your video and the audio? It's possible. So you can check your computer. The top one has like some of the audio and the video. Could you turn off your video and the audio? So yeah, could you check? And then only turn off. Could you turn off your video and the audio? Yeah, it's good. You can turn off on the video. Turn off your audio. Could you turn off your audio? Could you find some type of audio? Could you turn off just to make mute, M-U-T-E? The next one is like cosine of x. Was it like antiderivative cosine of x? The same idea. Which function prime is cosine of x? Yeah, you can do some the mute in Zoom. It's possible. Could you the mute in Zoom? Okay, thank you. So here, which function prime is like cosine of x? No, you cannot find. You cannot find. Use some the tone on your video, I think. Could you stop the video and the mute? Could you find in Zoom? You can go to Zoom. You just only mute, M-U-T-E, and the stop video. It's possible in Zoom. Yeah, you turn off your some of the video. It's good. Turn off your audio. Did you find? Did you find? No. You didn't turn off. Could you turn off your like some audio right now? Because sometimes the other guys cannot hear my voice clearly. So you can turn off your audio, please. So here, which function prime is cosine of x? So what do you think? So which function prime is cosine of x? Could you write your answer on the chatting board, please? Could you mute your some audio? You don't know? How can you turn off your audio? Oh, it's good. Yeah. Thanks. It's good. Here, so we have, yes, sine function. The sine of x prime is exactly the cosine of x. The antiderivative is sine. Was it like an antiderivative of secant square? We can use like the same method. Which function is prime is secant, tangent prime is secant square, tangent function. Similarly, the cosecant square of x. So antiderivative is negative cotangent. Was it like antiderivative of secant and tangent? So what do you think? Could you run your answer on the chatting board, please? So what do you think? Yes, the secant of x. Because here, the secant x prime is exactly same to secant x times tangent of x. So like this. So antiderivative of cosecant times cotangent is negative cosecant. This is exact table of antiderivatives. So we try to solve these problems together by using table. So here, f of x equals 1 over x cubed. So what's that? So we have x negative 3. You can find antiderivative. How can you find the antiderivative? Most general antiderivative here. So we can use this one. Was it like a function? Function is x to the n. Was it like antiderivative? Antiderivative is 1 over n plus 1 x to the n plus 1. You can use this rule. So negative 3 is like n. You plug into here. So we have 1 over negative 3 plus 1 x to the negative 3 plus 1 plus c. So we have the 1 over negative 2 x to the negative 2 plus c. So this is the minus 1 over 2. The x to the negative 2 is changed to the positive exponent 1 over x squared plus c. The final answer is negative 1 over 2x squared plus c. This is like a whole idea for solving this problem by using the table of antiderivatives. The next one. So how can you find this one? The same. Here, was it like antiderivative? So you have to use this one. The antiderivative of secant square of x is just tangent. So how can you solve this one? This is, you have to keep coefficient 3 times the antiderivative of secant square is tangent of x. So that's it. This is the idea. Here, how can you find antiderivative? You can use same things. So first one. So you have to keep 8 the same. Keep 8. Find antiderivative of x cubed. What is antiderivative of x cubed? Could you run your answer on the chatting board? What is antiderivative of x cubed? Was it like antiderivative of x cubed? So what do you think? What is antiderivative of x cubed? So antiderivative of x cubed is, do you know? Could you write your answer on the chatting board, please? So what's that? Uh, 1 over 4 x to the 4, the next one. So here, x to the n, the antiderivative is 1 over m plus 1, x to the m plus 1. The first one is here. The 3 is like n, we have 1 over 3 plus 1, x to the 3 plus 1. You can keep negative 9. What is antiderivative of x squared? Could you write your answer on the chatting board? What's antiderivative? The antiderivative is not 1 over 2. Here, same. So 2 is like power. You had change it 1. 2 plus 1. Oh, yeah, right. You're right. X 2 plus 1. Thank you. You're right. Yes, like this. You're right. So next to 2, This power is just 1. We have same 1 over 1 plus 1 x to the 1 plus 1 plus what is antiderivative of 7? Do you know antiderivative of 7? Yeah, thanks. The other guys, yes, 7x. So we have k is constant, antiderivative is kx. You're right. 7 times x plus general form, you can write c. And simplify. The 4 is crossed out, only 2. The 2x to the 4. The 3 is crossed out, change 3. So we have negative 3x cubed. The 2 is crossed out, only minus x squared. Remaining part is 7x plus c. That's it. This is a whole idea for finding antiderivative. The next one, in this case, so how can you find the antiderivative? So before you find the antiderivative, you have to expand first. So this is same to change it like this. The square root of x is exactly same to x to the 1/2 distribute x. The first one, x times x is x squared, keep negative. This is like power is 1. Power 1 plus 1 over 2 is the x to the 3 over 2 plus 3 times the minus 1 times 1 is x to the 0. X to the 0 is just 1. But that's it. Only 3 times 1 is like this. So we have it. The next find antiderivative by using same rule. So what kind of rule? This is very useful. So here, x to the n. The antiderivative is 1 over m plus 1, x to the m plus 1. So what's it like antiderivative of constant k times x? We use it. So this is same to 1 over the 2 plus 1, x to the 2 plus 1, minus x to the 3 over 2, same. 3 over 2 like n, the 3 over 2 plus 1, x to the 3 over 2 plus 1, plus 3 has 3x plus c. The next simplify 1/3 x cubed. So minus 1 over 3 over 2 plus 1. So 3 over 2 plus 1 is 5 over 2. We have to flip 2 over 5. X to the 5 over 2 plus 3x plus c. So this is a final. I want to change this one to the radical form. Radical form is like this. The negative 2 over 5. The square root of x to the 5 plus 3x plus c. This is the final answer, like this. The next, this one, the same. So we don't have antiderivative of 2x to the 5 minus root x over x. How can you do that? You can split the second part, 2x to the 5 over x minus x to the 1/2 over x. The next, simplify more. Here, 1x is crossed out, change for exactly 2x to the 4. This is a power is 1. The power 1/2 minus 1 is negative 1/2. The next, find antiderivative. So you can keep for what is antiderivative of sine. What's antiderivative of sine? Do you remember? Antiderivative of sine? Yes, negative cosine. Thanks. This is negative cosine. So like this. You can keep negative cosine. Here, similar. Plus 2 Antiderivative is 1 over 5 x to the 5 minus, here you can use power rule, 1 over negative 1 half plus 1 x to the negative 1 half plus 1 plus c. You simplify negative 4 cosine of x plus 2 over 5 x to the 5. The minus 1 half plus 1 is 1 half. You can flip only 2 x to the 1 half plus c. You can only change back to radical form. You have to keep this one plus 2 over 5 x to the 5 negative 2 times square root of x plus c. That's it. This is the whole idea. The next one, we think about one definition. An equation that involves the derivatives of a function is called a differential equation. Here, do you know what is an antiderivative of f prime of x? Do you know what is antiderivative of f prime of x? What's that? So what is an antiderivative of f prime of x? So what is the answer? What's the antiderivative of f prime of x? So what do you think? F of x? F of x? You're right. Yeah, thanks. Here, f of x prime is exactly f prime of x. The antiderivative of f prime of x is inner one, f of x. Yes, just f of x. So like this. So what is antiderivative of a second derivative? Antiderivative of second derivative is, yes, similar. F prime of x, you're right. F prime of x, the same reason. So we have f prime of x prime, the same to second derivative. So second derivative, antiderivative of second derivative is f prime of x. Next is S of t is position. The V of t is velocity. A of t is acceleration. So what's like a relation? The V of t is S prime of t, position prime. The A of t is V prime of t. So this is a second derivative of S of t. What is antiderivative of A of t? The antiderivative of A of t is, what's that? Yes, V of t. This one, because, so the reason is very simple. The velocity, the prime is A of t. The antiderivative of A of t is V of t. What's the antiderivative of V of t? What's the antiderivative of V of t? Yes, S of t, the same reason. Because S of t prime is V of t. So antiderivative of V of t is S of t. This is whole idea. The next thing, so we try to solve differential equations. Find f of x if f prime of x equals x times the square root of x and f of 1 equals 2. So here, so not easy, you can change it. X times square root of x is x times x to the 1 half. You can add it. Power is 3 over 2 because this is a power is 1. Power 1 plus 1 over 2 is 3 over 2. Next, find f of x. F of x is antiderivative of x to 3 over 2. You can use same formula. X to n is given. What's antiderivative? 1 over n plus 1. X to the n plus 1. You can use it. So this is exactly 1 over 3 over 2 plus 1 x to the 3 over 2 plus 1 plus c. To simplify, the 3 over 2 plus 1 is 5 over 2. You can flip 2 over 5. X to the 5 over 2 plus c. So this is not a final. You can decide c by using this information. F of 1 equals 2. You can use f of 1 equals 2. So what's like f of 1? You plug 1 into x here. So we have 2 over 5 times 1, 2, 5 over 2 plus c. This f of 1 equals 2. This is 1 to the 5 of 2 is 1, only 2 over 5 plus c equals 2. You subtract 2 over 5 from both sides, cancelled, the c equals 8 over 5, the 8 over 5. You can plug this value into here. So we can find final answer. Final answer is like this. The 2 over 5 x to the 5 over 2 plus 8 over 5. So I want to change it to radical form. 2 over 5, this is square root of x to the 5 plus 8 over 5. This is whole idea for solving this problem, like this. So let me see. Second one. So you can find f if second derivative of x equals 12x squared plus 6x minus 4, f prime of 1 equals 7, f of minus 1 equals minus 11. So the same. You can find f prime of x first. You can use antiderivative of second derivative. So this is 12 times what is antiderivative of x squared? What's antiderivative of x squared? What's antiderivative of x squared? We can use formula. Yes. The 1 over 2 plus 1 is here. Only 1 over. Bottom one is 2 plus 1 is 3. X cubed. Yeah, 1/3 x cubed. So like this, plus 6 times what is antiderivative of x to the 1? This one is, yep, 1 over 2x squared. What is antiderivative of minus 4? Yeah, thanks. Minus 4x plus c. And simplify. So we have like this and simplify. The 4x cubed plus 3 is right. 3 is crossed out. Just 4. 2 is crossed out. 3. We have it. This one. The next, you can find c. How can you find c? You just only plug 1 into here. You can use this one. You plug 1 into here. So what's that? We have like this. You plug 1 into x. You plug 1 into x. Into x. So we have the 4 times 1 cube plus 3 times 1 square minus 4 times 1 plus c. So this is the same to the 1 cube is 1, only 4 plus 3 minus 4 plus c. Oh, one more is equal to what? 7. 7 equal 7. the 4 is cancelled. So we have the 3 plus c equals 7. You subtract 3. The c is 4. You can plug into here. So we have f prime of x. F prime of x is the 4x cubed plus 3x squared minus 4x, c equals 4. So we have it. So like this. How can you find f of x? We can use same method. Find antiderivative. 4 times antiderivative of x cubed is 1 over 4. X to the 4 plus 3 times antiderivative of x squared is 1/3 x cubed minus 4 times this power is like 1. Antiderivative is 1 over 2x squared. Antiderivative positive 4 is 4x plus c. You have to cross out 4. We have x to the 4. Cross out 3 plus x cubed. Cross out 2, negative 2x squared. Plus 4x plus c. So we have it. This is like f of x. So how can you find the constant d? So we use f of minus 1 equals negative 1. You can plug the minus 1 into x. You plug minus 1 into x here. So what's that? We have like this one. So minus 1 to 4 plus negative 1 cubed, negative 2 times minus 1 square plus 4 times minus 1. So here, minus 1 to the 4 is 1. Minus 1 cubed is negative 1. So minus 1 squared is 1. 1 times negative 2 is negative 2. So 4 times minus 1 is negative 4. Plus d equals minus 11. 1 is cancelled. So we have negative 6 plus d equals minus 11. You add 6 to the both sides. What's like d? The d equals minus 5. d equals minus 5. So like this. You can plug the minus 5 into here. The final answer is x to the 4 plus x cubed, negative 2x squared plus 4x minus 5. So that's it. This is the whole idea for solving differential equation. The next one is a little bit different. The second derivative is given. The f of 1 equals 7, f of minus 1 equals negative 11. This is a little bit different. In this case, you can solve like this way. F prime of x, you have to find antiderivative. So what's like antiderivative? The same things. Here, keep 12. The x squared, antiderivative is 1/3 x cubed plus 6 times the x to the 1, 1 over 2x squared minus 4 has negative 4x plus c. So same to 3 is crossed out, change 4. The 2 is crossed out, change 3. So we have 4x cubed plus 3x squared minus 4x plus c. Could you decide C right now? Could you find C so far? No, because we don't have f prime of something. So we don't have it. Just f of 1, f of minus 1. What does it mean? You have to keep going. Find f of x. What's like f of x? Same. Find antiderivative of this one. 4 times 1 over 4 x to the 4 plus 3 times antiderivative of x squared is 1/3 x cubed. negative 4 times antiderivative of x is 1 over 2x squared. So C has only C times x plus another constant D. So you have to cross out 4, cross out 3, cross out 2. Answer is x to the 4 plus x cubed negative 2x squared plus cx plus d. So like this. This is f of x. The next is, how can you find c and d? So we can use these two conditions. F of 1 equals to 7. You plug 1 into here. Here. So what's that? 1 to 4 plus 1 cubed, negative 2 times 1 square plus c times 1 plus d equals 7. So what's that? 1 to the 4 is 1 plus 1 cube is 1, negative 2 plus c plus d equals 7. So canceled exactly c plus d equals 7. So we have it, first equation. Second one, you can use f of minus 1 equals to minus 11. You can plug the minus 11 into x here. So we have it and calculate. So minus 1 to 4 is 1. Minus 1 cube is negative 1. Minus 1 squared equals 1. 1 times negative 2 is negative 2. So this is negative c plus d equals minus 11. 1 is cancelled. You just only add 2 to the both sides. So 2 is cancelled. Negative c plus d equals negative 9. So we have it like this. So how can you find c and d? You can combine these two equations here. So we have c plus d equals 7. The negative c plus d equals negative 9. You add these two equations. The c minus c is cancelled, only 2d equals 7 minus 9 is negative 2. Divided by 2. So 2 is cancelled, was like d. The d equals minus 1. You can plug d equals minus 1 into either one is fine. Plug here or here, we have the same answer. And plug into first equation, c minus 1 equals 7. You add 1 to the both sides. What's that? The c equals 8. We have two numbers. You can plug these two values into f of x here. So c equals 8. d equals minus 1. That's it. This is final answer. So like this. That's good. So one more. A particle moves in a straight line and has acceleration given by at equals 60 plus 4. Its initial velocity is v of 0 equals negative 8 centimeters per second. And its initial displacement is s of 0 equals 6 centimeters. Find its position function s of t. So we can use antiderivative here. How can you find the v of t? The v of t is exactly the antiderivative of acceleration. So what's that? 6 times the t to the power 1 antiderivative is 1 over 2 t squared plus the second one 4 times t plus c. This is 2 is crossed out, only 3t squared plus 4t plus c. How can you find c? How can you find c? How can you find c? Yes, you can plug 0 into t by using v of 0 equals negative 8. You plug the 0 into the here, exactly v of 0 equals minus a. We can use it. What's like v of 0? 0 into t, 3 times 0 square plus 4 times 0 plus c equals minus a. So 0 and 0. What's c? C equals minus a. You plug back to v of t. So v of t is 3t square negative 4t minus a. This is like v of t. So like this. Next, find s of t. What's like s of t? The antiderivative of v of t. You keep 3. Antiderivative of t squared is 1/3 t cubed plus 4 times. Antiderivative of t is 1 over 2t squared plus, sorry, not plus, this is a minus. Negative at plus constant d. Cross out 3, cross out 2, only 2. So we have t cubed plus 2t squared minus at plus d. How can you find d? How can you find? Yeah, plug 0 into t. Yes, the t. So you can use this one. S of 0 equals 6. We have S of 0 equals 6. You can plug 0 into t here. Plug into here. So we have 0 cubed plus 2 times 0 square minus 8 times 0 plus d equals 6. So 0, 0, 0. What's that? D equals 6. The last one, you plug this value into t. The final answer is like this. S of t is the t cubed plus 2t squared minus 8t plus 6. So that's it. This is the whole idea for solving this problem. The next one is the last problem. The graph of a function f is given. So make a rough sketch of antiderivative capital F given by capital F of 0 equals 2. So here, this is what? Y equals f of x is given. Y equals f of x is given. How can I sketch the graph? So here, so we know that f prime of x equals f of x. So we can use increasing, decreasing test, concavity test, and the first derivative test. This is the whole idea. So we just only use this one. Do you know what's increasing, decreasing test? Increasing, decreasing test is, remember? Capital F prime of x is positive. So what does it mean? Graph of f is increasing. Yep. The capital F prime of x is less than 0. The graph of f is, yes, decreasing. So do you know concavity test? We have two kind of things better. Here, I want to use this is better. So we think about what's it like second derivative is positive. Was it like capital F concave? Up. The second derivative is less than 0. The capital F is concave down. This whole idea. I'm going to use another one. Here, f prime of x f prime of x is what? Increasing. So what's it like f? Capital F is concave up. F prime of x is decreasing. F is concave down. This is concavity test. That's good. So we use this kind of things. You can just split. You can draw the graph like this. How can you sketch the graph? So we can just split the some part here. This is like 1, 2, 3, 4, and so on. This is 1, 2 here. So what's it like f of 0 equal to 2? You can plot here. What is 0 to 1? So this is little f is exactly f prime of x. Here, f prime of x is this one. The first one, graph of f is increasing or decreasing? Increasing or decreasing? So what do you think? Interval x is from 0 to 1. The graph is increasing, decreasing, decreasing, because f prime of x is negative number. The less than 0, we can use this one. Graph is decreasing. So one more. From 0 to 1, so concave up, concave down. Concave up or concave down. So what do you think? Concave up or concave down? Concave down. Because I don't think so. Concave up. Was it like f prime of x increasing? F prime of x is increasing, concave up, is right? This graph is f prime of x is like increasing, yes, concave up, concave up. Graph is decreasing, concave up. What's that? Graph is decreasing, concave up, decreasing, concave up. So like this, decreasing concave up. 1 to 2. X is 1 to 2. What's that? Here, graph is above x-axis. Like, yes, increasing. So graph is increasing again, concave up. Graph is increasing, concave up, increasing, concave up. So like this. We have local minimum at 1. So next, x value approach, x is between 2 and 3. Exactly this part. So same, positive number increasing, concave up or down? Concave down, because f prime of x is decreasing. The decreasing, concave down. Concave down. Graph is from here, increasing, concave down. So like this. The next is 3 to 4. X is 3 to 4. 3 to 4, we have this portion increasing or decreasing. Graph is decreasing because below x-axis. F prime of x is less than 0, decreasing. Concave up or concave down? Concave down because graph is decreasing. Concave down. So what's that? Graph is decreasing, concave down. Here, local maximum. So one more. What happens to? This is inflection point. Concavity changes. This is inflection point. Concavity changes at 2. So was it like a 4 to infinity? X is greater than 4. So graph is below x-axis. We have decreasing. What's concavity? Concave up or down? Concave up because graph is increasing. Concave up. So concave up. So graph is here decreasing concave wall, like this. This is another inflection point. This is inflection point. Okay, this is like a whole idea for sketching the graph f, the antiderivative of f by using derivative. Okay, so like this. Yep. Okay, so this is like all for today's lecture. So if you have any question, could you write your question on the chatting board? So if you don't have any question, so you can leave this like live session. So thank you for attending my class. I appreciate it. So, yep. The any question, the right new question, yeah, you're welcome. So if you don't have any more questions, you can leave live session.